So now what is happening is that we have a solution of copper. We have a solution of aqueous copper sulfate. We have a solution of copper sulfate. But instead of electrodes being inert electrode, now we are using the electrodes which would be active. So we will have a setup like this. Roughly, we will have a setup like this. I'm making a rough figure here. That we'll have a these two would be copper electrodes. This would be the positive terminal. This would be the negative terminal. I'm not showing the cell. And we will have a electrolyte of aqueous copper sulfate. Now, what are the electrolytes from? What are the ions we'll be having? We'll have ions like Cu2 positive, SO4 negative. These will be coming from copper sulfate. We will be having H positive and OH negative. This will be due to the aqueous part. We have active electrodes. So these active electrodes would be taking part. So now we can very well rest assured that it is only the Cu2 positive which will be getting oxidized and reduced. We don't even have to worry about sulfate or hydroxide or H positive. It's the Cu which has taken part of this electrolysis process. So these are the easiest. Whenever you see an active electrode will be doing all the dance. So at anode, this is the reaction which will be taking place. Positive terminal, here there will be a discharge of 2 electrons. So at the positive, you can assume it like this. Just for your understanding, you can look at it like this. That 2 electrons would be pushed up and Cu2 positive will enter the solution. So this Cu2 positive will enter the solution and these 2 electrons will go up towards the positive end of the cell. So this is what is happening at the anode. At the cathode, the negative terminal, the right side, that I've discussed again and again, that always maintain this consistency. The positive electrode, let it be towards the left side, and the negative electrode, let it be on the right side. This is the consistency that you can maintain, so that you don't get confused and you do all the questions like we have done to 10 to 15 electrolysis cases. So this will get hammered in your brain. So at the cathode side, again, Cu2 positive will be taking part. The Cu2 positive now will gain 2 electrons from here and will get discharged as Cu. So this, you will see a layer of Cu here. You will see a reddish brown layer of Cu here. So this is actually called the purification of copper. This is used in the purification of copper, where we want to increase the concentration of copper. So we will have the impure copper on this side, and we will have pure copper on this side, and we will see that as the reaction goes on, this impure copper, this decreases in size. This will decrease in size because the movement of copper is taking from the left hand side towards the right hand side. But now the interesting thing is the Cu2 positive, due to the concentration of Cu2 positive is maintained. So the color of the solution won't change. This blue color will remain the same. It won't get affected like it got faded in the previous example where we had taken inert electrodes, but now the color will remain the same. And that is why they have asked questions like these. State whether the mass of the cathode increases, decreases, remains the same when copper electrodes are used. Of course, the mass of anode mass of anode will decrease. Mass of cathode will increase. I've told you this anode would be the impure part. Describe the change in appearance of the electrode when copper electrodes are used. The electrolyte, the blue color will remain the same because the concentration of Cu2 remains the same. So this is an interesting question, and because it requires a lot of understanding in terms of you should be aware of the effect of the electrodes, whether they are active or inert.